here so I can see messages you guys come on and have anything to say. I can never remember what they call this. Stream Manager, that's the one we want. Righto. Well, I think we're on now, so that's all good. So, what I'm trying to do at the moment is to debug the internal floppy drive. So we have in the MEGA65, as many of you will know already, an internal floppy drive. So I've got the case here a bit wonky, but you get the idea. If we lift that up, you can see we've got a 3.5-inch floppy drive. And so I've got a disk in there. This is my core Victim 720K disk that I'm doing lots of testing on. Hey, 6502 Kebab, welcome along. And I can read from that just fine. So that's all good. And I've been working on writing to it. So I'll show you with a test program. I'll just load up. Okay, so this funky test program, it's deceptively named. If I press 7 for sector write testing, it's also let me do read testing. So this is a native program on the MEGA65. It's running in 80 by 50 text mode. And so I can tell it I want track 0 and I want to read a sector from the track here. And so we can see that it's red and it's got this funny written to track 0 sector 1, because that's what my test program writes in there. The rest of the sectors are blank because this is a disk that's been formatted using the C65 DOS, and that formats the sectors all empty, which is all fine and good. And I can just show you here. You can see where I'm typing, so I can I've set up a bunch of keys so I can change what's going on. So if we want to read from track 1, we can do that, and it's done there in a fraction of a second. So this is all good. So pressing R will read from it. If I press W, it will write something in there. So it shows some junk at the top of the screen. And if I do R again, it says when I read the sector now, it has written to track 1, sector 1, side 0, because that's what I'm writing when I do the write test, so that I can see that I've done it. So that's why we had something similar on track 0 there, because I had done that earlier. So we know that the controller can write to real disks. So this is some work that I've been doing over the last week or so. I'm actually really happy that we can actually write to sectors now, and the CRCs are right and everything. There'll be a blog post coming out once I've finished debugging these last issues. And the last issue we have, or rather the current issue that I'm trying to solve, if we let the machine reboot, and if we go in and we will choose the internal drive, we try and read from it, we'll get a 74 or some other error. So now the 74 error, it's a little bit interesting. I think it's because the head may not be on the right track or something funny like that, or it could well be related to this whole problem that we've got. So if I do a quick format, so if I want to do a full format, I'll have to do a comma I and a 2-digit number. So a quick format doesn't try to do a low-level format of the disk, it just tries to read the sectors and update the BAM and everything. And so we say yes, and so you can see the light for the floppy drive came on, and now we get this 27 read error on track 40. So the 27 read error happens when the DOS thinks the floppy controller can't find the sector header, or that has a CRC error in it, which also means that it won't get read. So this is a bit of a mystery, right? Because we've seen in that test program that we can read sectors, and in actual fact, if I put a disk in that has files on it, it should, unless there's something really wrong going on here. Oh, that's interesting. There's probably a clue in that somewhere. Okay, so drive not ready. That's weird. I'm just going to reset the MEGA65 and we'll go through and tell it we want internal driving in. It should. Unless I bought the disk up. I don't believe I have. Run my test program because I can actually try and, one of the other functions it has is to actually try and read every sector on a disk and do that quickly. So number 2, test all sectors on a disk. Right, so it's reading fine. We may have an issue with the change line stuff, so it might be that the C65 DOS just got confused about the disk. But we can see that disk is fine. So let's just reset again. And now tell it. Reset disk. Oh, that's really weird. I'm going to try and read the directory track and see if it's. What track we're asking for versus what track we're on can be different in this test program on purpose. So 20 track, yep, that's the right track. Yeah, see now that's reading just fine there. There is no sector 0 because sector numbers are numbered 1 to 10, so that's as expected. Okay. So maybe we're actually the same bug, it might actually be being tickled here, which is potentially useful. So I'm curious as to what sector is really trying to read. Everything composited over the top. Now we've got matrix mode composited over the we're typing into the matrix mode there. That's actually really interesting. The display you can see on the screen there has the left edge of it is actually properly visible, but I've got a separate HDMI screen off to the side here, and it's actually clipped down the left side a little bit. Yeah. Probably not relevant though. I won't remember the wrong address here. FFD3080. Oops. I can type. Okay, so this is the floppy controller registers. So the first of those will be D080. So the FFD3, the first part of the address, is giving us the memory context that we're using. I think actually the monitor we can do. That's supposed to take an argument from the address to see memory from the CPU's context, but that's fine. So we've got these three. Well, there's a bunch of registers here. So if I point. This first one here with 08 in it is the it's the first control register. So if we want to start the motor on side 0, we put 68 hex in it, and that would turn on the floppy drive motor. You probably can't quite see the LED for that. And we've got so we can do this. So you can see now the drive LED is on and running. So that's that. And again, if I try and point up here, so we've got the 68 for that. We've then got 46 of DO81. I'm trying to remember what's in DO81. I think that's the command register. Then the next one should be that's the status 2 register. And DO83, I have to check that one. Oh, sorry, so DO83 is another read status register. So that has things like whether the disk is whether a read request, whether the sector was found or not when it was doing the request. So MFFD303. So that's got 08 in it, so that's bit 3 only. So it says there is a disk present, but that the read and the write request flags have come back with nothing. What we care more about is DO82, so that's FFD302. So that's got 13 in it at the moment, so that's the bottom 2 bits. So bit 0 is that the head is over track 0, so that's set, that's fine. Bit 1 is that the write protect flag is set, so this disk has a write protect tab on. And then it's bit 4, RNF, request not found. So it failed to find the sector it was after. So it was presumably trying to read, well, not presumably, it is trying to read 5308. 4. So the, oops, get my finger lined up again. The 27, so these are all in hex, of course, right? So 27 is 39 in decimal, so that's the track number. Then we've got sector 1, side 0. So that's what it's trying to read. Now the trouble is that it seems to be that it's actually, we saw from that previous status register that that's on track 0 at the moment. So if I go set FFD3081 to 40, so this would command it to do a read. Oops, if I can type, it would be really helpful, wouldn't it? So again, we're seeing this same thing where we're getting the, oops, where is it? Can we finger? 13 hex. So this bit 4 is set. That one tells us it couldn't find it, which, as we say, makes sense because the disk is on track 0, not track 39. So if I try to load the directory, we should hear the drive step to go to track 39. No, it's not. This is very weird. What I might try and do, so I'm going to try and put a watch point on FFD1081. So this is the same as having the FFD3081. So this is the DO81 register from the C65 memory context, which is why it's FFD1, not FFD3, which would be the MEGA65 context. So in theory, this should stop the CPU every time the floppy command register is written to. So, which is not. FD3, try there. There have been problems with these right watch points. Nope, so that's not working either. So why is the DOS not seeking, and how am I going to debug that that's the case? Because that's really, really weird. This disc has got tape on the hole to make it into a 720 instead of a 1.4. That gets a bit jammed in my drive here. So let's manually step the head. Right, so that's stepping it. I can hear it step. I don't know what, you probably can't quite hear it with this microphone that it's stepping, because it's quite quiet when it does just a single step. So either the DOS at some point is asking the drive to step and it's not, or maybe it's getting confused and the busy flag is clearing too fast after we do a step or something, so it's doing lots of steps really fast and resulting in the steps then not working. Maybe that's what's going on. I'm inclined to have a look at the C65 DOS and see what that has in its step routine. So I'm going to plug in HDMI from my laptop into the grabber here so that we can see it. Okay, and I need to change my view of that so I can see that full size. Okay. So here's the C65 DOS, step out. So this init controller routine prepares the controller to do a sector operation. So it has stepping in here. So it tries to do a step in, does the command, so the command reg routine. I think we will see. Yeah, it literally stores it into the command register and then it waits until the busy flag clears. So let's find where I'm stepping. That's in the histograms. That's reading sectors. So I've got, you see some of these spots, I am checking the busy flag, but what I want to do is have a little routine that lets us do a step and then show how long the busy flag stays for. So we have, here is our step commands on the plus and minus keys that I was using in the thing before. So let's do while peak OXD08 2 and OX80, so that's the busy flag. going to make the border color animate while we wait for the flag to clear. Do that one step in both directions. So it's supposed to stay busy for some number of milliseconds. So let's go. Those who don't already know, I like to work on the command line from Linux to do things, to automate things. So I've got run. Oh, because I have matrix mode running on the MEGA65, it won't kick in. Right, so let's go into there. Okay, so hit the step command, and either I'm checking the wrong register, or it never indicates that it ceases to be busy. So DO82 is the busy flag. So if we do a step, we set the busy, and we set the busy countdown. Same stepping in the other direction. And we have a counter that counts down the number of 16 kilohertz ticks. When it gets to 0, it should zero it out and cancel the busy signal. We have no visibility on that register, but let me just D3082 is not got the busy set. Okay, so what's wrong in my code that it's sitting there in a loop? Oh. Yeah. If I put my brackets in the right place, the code might work. That would be a delight. Again. Okay, so you're seeing it's some fraction of a frame. And it's a reasonable fraction of a frame. That we see the colours cycling through. So, and if I hold it down, it's the key. Well, it's probably not really seeing but it's stepping quite happily. So it can step. That's good. Why is it not doing it from less than 65 dots? So something is clearly going wonky there with that. What I can do, let's try and think about how I'm going to debug this when it's running the ROM code. So we can run the CPU in this trace continuous mode, where it will log instructions continuously. The trouble with that is you can see the cursor stop blinking. This is because we've got interrupts running. And with single tracing the CPU like that, it's running so slow that it doesn't get to the end of the interrupt routine before the next interrupt is required. So whilst that would be a great way to debug what the CPU is doing, in practice, it's not going to work for us. Why is the CPU now not? Something has crashed on them. Not quite sure what was going on there. So that unfortunately isn't an option for us. Hum. How am I going to check? Because this is why I made the test program, right? So I didn't have to use the ROM code. I could have this kind of, tame routines accessing the floppy drive. So something is wonky in the ROM, and I presume if I... see that? That's weird on two fronts, because that disk is not empty. But we are at least seeing the disk return, so we must have seeked to the right track at some point. Yeah, we've got the disk change line is not working properly yet, which I need to figure out a solution to without making the drive tick like on an Amiga. This is a little bit frustrating. I'm not sure I'm actually running the correct bit stream. That's interesting. So that seeks back when we switch to the drive. It seeks to track 0. Oops, 5. What I can't remember. There is an SYS code that will go back into C65 mode from C64 mode. What I wanted to see, because when we switch modes, I believe it resets the DOS. So it recalls the init. So here we can see we have the correct header on the disk, drive test, and it has all of these files on it. So when in the freezer we tell it to use the internal drive, it seeks the drive back to track 0 because it thinks that that's the right thing to do, so the disk is where it should be. But it might be that that's no longer the case, that we're actually better to leave it on the track that the DOS thinks it's on, so that it seeks to the correct track and doesn't get these errors about which track it thinks it's on being wrong, effectively causing it to try and read the wrong sector from the track. So we used to have this auto-tune thing where we would make the drive check whether the requested track was the actual track and then seek to the right spot. Glad you're finding it interesting, 602 Kebab. I'm finding it a little bit frustrating at the moment because of not getting any really solid clues as to what's going wrong, but that's right. So I'm going to try the freezer and modify that to not seek to track 0. So it must be freezer disk chooser. Freeze disk chooser. Okay. Seek. Right, so here we have mount succeeded. Now seek to track 0 to make sure the DOS knows where we are and to make sure the drive head is sitting properly. Now, as I said, this is actually causing trouble now. So we're going to leave the drive on whatever track the DOS thinks it got the head to. Now this might still cause some grief, I'm not sure, but sounds like a more sensible default at the moment. So we'll go in, make freezer.n65 n65 ftp -c put freezer.prg. Oops, not m65, sorry. Again, I like to automate things, so let's run the MEGA65 FTP, which is file transfer program, not protocol. It's not over Ethernet, it's actually over the serial monitor interface. So that empty disk is what was on the disk image. So we're going to switch to internal disk. No, it's our internal drive. In theory, it shouldn't have seeked onto the wrong track. It didn't chug when I did it, which is a start. So DO82 is showing 30, so the drive thinks it's not on track 0. But man, I don't have a really easy way to see what track it's on. Do I? Oh, actually I do. If I turn the motor on again, oops, I'm typing on the wrong keyboard here. D308068. Right, the disk is spinning. Now, what we have D6A4, I think it is. Right. We have the track sector and side number that most recently went over the head, so D6A3. If I come back here, do this a couple of times. So we can see we have the right spot. Okay, now we can see my finger again. Right, so we've got track 4E for both, and then the 80 is the side number. Ignore the most significant bit, that just means it's matching the side it's asking for. And then we have track numbers here, so sector numbers of 4 and 6, so that's changing constantly as we go through. So 81, so that means it's sector 1, and that we were looking for a sector 1, but the track number's too high. So what I can do, because we know that it was looking for FFD3080 track 27 is in the fourth byte of that. So if we go set FFD3081 10, that should track towards step 0. Indeed, now we're on track 4D, so if I do that a bunch of times and pull the head back to the track that it thinks it's on, we should then be able to do a directory and not have it fail, because this delay is while it's trying to read from the disk. Set FFD3 081 10. I'm actually going to do this now from the Linux command prompt, because I can copy and paste the command and run it a bunch of times. And that's good, I can hear it seeking as I do that. I just need to highlight this. I go. So here's our command to do the stepping. What we want to do is to highlight it as a whole line. Right, so copy it and I can go paste. And I can hear that stepping. Again, if we type the address incorrect in a correct manner, and turn the drive on. Okay, we're on track 3.6. We want 2.7. Right, so it's showing A7, which is 2.7 plus 128. So that should be the track we're looking for. So if I do a directory now, we get it. Okay, so that's helpful to know, because that tells me that we're not always setting the head to the track that we should, that we're looking for. So I'm going to put my guinea pig disk back in. Try and get the directory of that. And that's hanging. This is interesting. So it's the track number is correct. The track we want is 2.7, the sector is 01, and the side is 00. Have a look at that. So this should, in my view, be returning, because that will eventually say it can see a sector 1. Except it's not. I've got 2 of these blue discs here. It's possible I put the wrong one on and that one's not actually formatted properly. But we can deal with that. Let's boot back into C65 mode. I'll try and do a directory. Oh, that's a deal, because it'll lock up again now, right? What I want to do is to format this disk header, MEGA65 disk 2. We'll do the comma I65 on the end, so that should tell it to do a low level format. So last click we're sure. Now the screen will go blank for a while that chugs through.
I'm ready to fly.
I'm not sure, you might just be able to hear the drive ticking away quietly in the background. I'll move the microphone around a bit. Hey Marauder, welcome along, glad you're enjoying it as well. Yeah, unfortunately I do the streams really at quite random times when I get a chance, so it's a bit hard for me to predict ahead of time when that will be, but that's alright. So anyway, so it's going through all 80 tracks, formatting those at the moment. Yeah, that's right, you're in the UK, so the time zones are a bit funny. So I normally actually do them at time, well yeah, it's quite late at night for the UK normally when I do them, because I would normally do them at silly 100 local time here, before the family get up. But tonight actually they've all gone to bed early, and I'm not totally toast yet, so I thought I would do a little bit now, so it's probably a better time for you folks over in Europe. And this is where we remember just how long it takes to format a disk. Okay, so this is the problem that we see when we finish formatting a disk. We get this 27 read error 40. So again, let's see what track we're actually on. So I think we're not on the right track, but it looks like we are, because we've got A7 for the track, so that means we're on track 27 hex, which is 39 decimal, and the tracks are numbered on the disk 0 to 79, whereas on the C65 DOS it treats them as track numbers 1 to 80. Okay, sorry, so 602 Kebab, you were asking, my full-time on the MEGA65, or do I have a day job as well? Yeah, I have a day job, which I've actually just taken up a different job to the one I had before. And this one's actually quite nice in that I really am only working 40 hours a week, and then I'm a bit freer in the evenings and weekends to think about other things, whereas when I was working at the university, it's pretty standard fare for academics to kind of get, if you want to succeed as an academic, you have to work a fair bit of overtime to try and get enough research done, and and just do all of the things that need to happen. So yeah, I'm glad to have left that patch behind me, and yeah, have a job that gives me a little bit more brain space to myself at home in the evenings, and yeah, it's good. So okay, so it's got the right track, so we're getting this read error, so let's try to have a look at what's in the floppy controller registers and see what we've got there. Whoops. MFFD. So if I can type the address correctly. Okay, so we've got 08, so the motor is not running. We've got 80 in DO81, so that's the command register. In the status register, DO82, if we come back up here, DO82, we've got bits 4 and 5 set. So RNF means request not found, so it means that the sector that it was asking for wasn't found. So this is interesting. FD36A3. Talk about luck. So this is again is showing the most recent sector that's gone under the head. So if we turn the motor on and watch it again, we'll see that change in theory. But again, what we're seeing is the track is A7, so that's 2.7 with bit 7 set to say that's the track we're looking for. We've got sector 1 with bit 7 set to say that's the sector we're looking for, and we've got side 0 set with bit 7, so that's the side we're looking for as well. So this looks to me as though the read operation should have succeeded. So in the return code from that, we've got bit 4 set. DO82, if I scroll that down a bit, we can actually have that. Whoops. Sitting where we can see it. Under there. So DO82, bit 4 is request not found. So this is saying that they couldn't read the sector. So if we request it to read again, we've got 68 saying the motor is running, 40 that's our command that we ran. And now we've got 44. So lost. So command 40 is a non-buffered read. We want to do a buffered read, so we'll put 46 in. So this will just read it directly into the sector buffer. And I've brought something up here. So let's clear the error status. Do the read. I messed that up. So it should be buffered. Yeah, those bits don't matter. So the read command is MEGA6, so that makes it 40. Something has got confused there, I think. So this might be evidence of the bug. It's cleared the ERQ flag. SFD3081 46. So that should command it to read it. Let's have a look at what I have in my floppy test program. No works. Okay, so we can ignore this stuff because that's doing fancy fiddly things that are unrelated. Make sure that we don't do anything until the error flag is cleared. We seek to the track 0, then we seek back to the track that we want. We put the track number sector inside into those registers. In DO81 we tell it we want to reset the positions in the read buffer, and then we want to command it to do the read. And then we just check the busy flag and check the results. So that should, with our bodgy test here, set 3080 1 to 1. So that resets the flags. So now we've got 20x in here, which is bit 5. So it's the EQ flag. That's good. So that says that the buffer is either empty or full because we've just reset the flags on it, which should be correct. And then we just write 40. And we end up with 4 in there. So the lost flag is set, i.e. the CPU didn't read data fast enough. Read only. So that claims to have read. FFD. What is this? FF? I'm just trying to remember the where the sector buffer lives. I think it's here, FFD6C00. So I'm going to write some rubbish in there. So the rubbish that we've written there, FFD3081, we will command it to read the sector again. And it's been written over with 0. So the reading of the sector has actually succeeded. Even though we have the lost flag set, but that's irrelevant because we're in buffered mode. So we can read it fine. So why is the DOS then getting an error? So if I'm just going to hit F3 on the C6, the MEGA65 again, and now it is reading something. It's reading rubbish, right? Because that's what's on the disk. So something I have done has got it back into a happier state. I wonder whether it wasn't that resetting of the buffers. So let's reset the machine. Read. Right, so now we get the drive not ready error. So let's So we're asking for track 27, sector 01, side 0. So I'll set the motor going. Again, we're seeing this mystery that we are on track 4E. Now, the thing that strikes me as odd about this is that track 4E is double track 27. So something thinks we need to step out 27 tracks, when in actual fact we already had a 27 hex tracks, when in fact we already had. So it's like the track 0 flag is wonky or something when we mount the disk. So let me just listen to the drive this time as well. So let's zip. We're on the internal drive. So I've turned the motor on. We're set to ask for track 27 hex sector 02 side 00. We're still on track 4E. Why are we on track 4E? So I'll reset the MEGA65. root problem here is that the DOS and the drive have a different idea of what tracks they're on. So as we're going from having a DOD1 image to the real drive, because as you can't check the real drive to see where it actually is versus where it thinks it is. What I could do is in the freezer, I could read out what track or sector was asked for last, and I could seek the drive to that track. That's probably as good a solution as I think I can think of at the moment. And that should get us away from this 74 drive not error ready when we put a disk in. It's still not going to solve the problem with the formatting because that's not happening at that time. As in the freeze menu isn't part of the process at that point. So, but let's do it anyway because I think it's going to make our life easier with this debugging process. So we have one less thing stuffing up. So we'll reinstate the code to seek the track 0, and then we'll say now check the contents of DO84 to find out the most recently requested track and seek the head to that track. So what have we got in the way of variables? We can do X. So go into the freezer. No, I can't remember the name of the function for doing the peaking frozen memory. There was one. Freeze peak, that's the one. Let's do the address. Freeze peak. 53084. So that's the get last request track frozen program while X. This is where we want to do the stepping. Want to do forward steps. So let's try and compile that. Update the freezer. Okay.
Вы слушаете радиопараллакс.
So let's go to C65 mode. Now, initially we're using a DOD1 image. So now let's go tell it we want to use the internal drive. Now we should hear the drive chug down to track 0 and back up to track 27. Ooh, funky noises. Let's going to stop that. See what track we think we're on. So we think we're on 4E again. So where? Oh, yes. Because I had this loop to do it, and then I'm not decrementing it, so we were doing it for an infinite number of tracks. So we were getting up to track numbers. Okay. That makes me happier. Make again. Put freezer again. So we have an internal disk. Switch to the internal drive. The drive chugs a bit. Hopefully. And it didn't work. But the idea was that should have got us synced onto the correct track. And interesting, it thinks we're on track 3. Rather than track 27, presumably, which is where, yes, so it thinks that we should be seeking to track 27. So that would have the correct value in it. I'm just trying to work out where it can be going wrong. Because it looks like it should be right now. I am starting to fade now, so I might have to sleep on that and try and think about what the problem with that can be. But oops, I'll turn that other monitor off instead to TV mode. Helpful. Yeah, so I'm just going to have to do a bit of a think and investigate. It's frustrating because it's so tantalisingly close. We can write to sectors, we can read from sectors, we can format tracks. And it's just this head management that's now proving to be the tricky bit. Because I did previously have this, what it's called auto-tune, where the head would seek to whatever track was requested, even if it wasn't on the right track, and that kind of covered a multitude of sins. But when the C65 DOS goes to format, it was causing it considerable grief because it would step off of track 0, trying to find track 0, and then it would start formatting track 0 onto track 1, so you'd end up with 2 track 0s instead of 1. And so then all the tracks were out by 1, and that was also resulting then in these 27 read errors because the it didn't, when it synced to the right track, the track numbers and the headers were out by 1. So I need to try and think about what really can be causing this to happen. When that really means I want a nice way to debug the ROM. So I'm going to have a look and see whether I can get the CPU breakpoints and watch points working properly. I thought I'd debug them, so I'm going to have to revisit that and find the bits of code in the ROM as well that I actually want to intercept and step through and see why on earth it's not doing the right thing. So, as I say, it's a little bit frustrating, but yeah, we are making progress, and we will catch you fine people next time. And thank you for the kind words there, Marauder and 602 Kebab. I hope it was a bit of 8-bit fix for you this morning or this evening, depending on time zone where you are. And yeah, we're all looking forward to getting the final machines out. It'll be really, really nice to have a bunch more in everyone's hands. So, cool. cool. Thanks again. And yeah, 8-bit should be the law indeed. We'll catch us all next time. See ya.